we had to weigh everything. We've got a scale over here actually. We had to weigh everything. So we put the whole payload on the scale. We had a balloon, and we needed to know how much the balloon would lift. So we got a fish scale, and we attached that to the bottom of the balloon. And then we got a reading, and when this said it would lift more than what the payload weighed, we knew that it would go up. And actually, we figured out that we needed about 2 pounds of extra lift so that the balloon could carry 2 pounds more. And then we typed those numbers into that website that Indy was talking about earlier, and it told us exactly how high the balloon would go and how far it would go and where it would land.
Actually, we didn't use the scales until the second launch. The first launch, we forgot to bring a scale. So someone had this piece of wood in.
Molding from my hallway.
Alright, this is molding from Laura's hallway. Drilled a hole in the direct center and on both sides evenly, and tied some string and had water bottles. And we knew that water was about 1 gram per centimeter cubed. So we just took a liter of water bottles and we're like, oh, you know, this is about ½ a pound, and just sort of put them on one side and put the payload on the other and waited for it to bounce. So it wasn't the first launch wasn't an exact science, but it worked out really well.
Actually, there was another trick after that. We knew exactly how much the balloon needed to be able to lift. So we had water bottles with just the right amount of water in them. We attached that to the balloon, and then when the balloon would just hold up those water bottles, they would just float above the ground, then we knew everything was just right. Got another question back here? It's a fish scale. A fish scale is a special scale that you don't stand on. You would say if you had a fish at a fish market, you would hang it from the hook, and it would tell you how much it weighs. But it also works the other way around. If you want to know how much your balloon will lift, you turn that around, connect that to your balloon, and you can see how much that balloon will lift. Right here?
Those are like, when it holds the balloon, does it like fly away with the balloon, or it tells the...
Well, you have to hold on to the balloon, make sure it doesn't fly away, and then we actually took the, I don't know if you can see where the nozzle of the balloon is tied off here. Oops. We have a whole bunch of duct tape there, holding it together, and then we put a bunch of string. You can still see some of the string that went through there, so we had that string to hold on to. So even as the balloon went up above our heads, we were holding onto the string. We were able to put string. So there's this duct tape here, rightly colored duct tape that would help us see the payload when it came down. But we had these strings coming off the payload. And we tied those to the string coming off the balloon, and we held on to all of this until we were ready for it to go. And finally, when we let it go, up into the air.
In the back?
Wait. How can a camera take pictures by itself?
Normally it doesn't, but we found a program called CHDK, which you basically run the software on your computer, and it changes the camera settings so that you can tell it to take pictures on its own. You hold down the, you change one setting with like the wheel, and then you hold down the photo button for a couple seconds, and then it's in automatic mode, and it just keeps on taking pictures until you turn it off.
And we had to find a camera that would run that special software.
Yeah.
And then we found out that Ms. Connie Gillies had a camera like that, and she was kind enough to let us use it.
dripping.
Yeah, probably dripping.
The lid is loose.
Look, two. See, that's not hard to take the beautiful lid.
Everybody wait.
It's not coming back. No, this one's not coming back. That's okay.
I can That's all fine.
Yeah, I mean, it looks hard. It's almost like a bird.